Good evening, all of you. Welcome to Unacademy. Today we will going to see our next lecture on Fourier series. That is, in the last lecture we have seen how to. Now we know that how to find out the Fourier series. In last lecture we have already seen, right? We already seen the how to find out the Fourier series. Full range Fourier series in the interval 0 to 2 pi and in the interval 0 to 2l in the interval minus pi to pi, and also for the even and odd function. Okay, now in this lecture we will see the half range. In this lecture we will see half range Fourier series, half range sine Fourier series and half range cosine Fourier series. Okay, now let's start. Before going to start this, let me introduce myself. Myself Dhanashree Mam. I completed my MS in mathematics from Mumbai University and also having 13 plus years of teaching experience. I mentored more than 10,000 plus students for the engineering. Okay. Now step 1, here I am going to tell you how to install the Unacademy's learning app. First go to your mobile's Play Store app, then search Unacademy's learning app. After that install the Unacademy's learning app and then manage your goal here. जैसे कि हम लोग अभी यहाँ पे GATE and ESE के लिए पढ़ रहे हैं, so you have to manage your goal. Then take any subscription plan either for plus subscription, free courses, special classes. हर plan का अलग अलग benefit है, so you can see it here. And then take get subscription. After that you have to subscribe for the months, that is either for 12 months, for 24 months, that it is up to you. अगर आप लोग GATE 2022 के लिए prepare कर रहे हो, then I will suggest you can go for the 24 months plan so that it is more beneficial for you. And if you want 10% discount on your subscription fees, then use my promo code, that is DSP, to get the 10% discount on your subscription fees. Now next is here, you can pay your subscription fees by using any one of this method, either by debit card, credit card, or by EMI or UPI wallets, net banking. Anything you can use here to take the subscription plan and to pay the fees. Okay, now the most important thing I'm going to tell you here, evolve for the batch GATE 2022 सिविल के लिए ये बैच हमारी स्टार्ट हो रही है फ्रॉम द 28 दिसंबर. ओके, सुबह 11 बजे से. ओके, 11:15 के बाद ये बैच स्टार्ट हो रही है. नाउ यू कैन सी हियर द टॉप एजुकेटर्स फ्रॉम द अनअकैडमी. हियर यू विल गेट अ प्रॉपर गाइडेंस अंडर all the top educators, so please keep in touch with that. And this is for the batch for the mechanical batch A. Here is also start from 28 December from 6 p.m. So please go through it and be there to attend all the classes, which is very helpful to you. Okay. Now to take any free subscription plan or to unlock the any free plan of Unacademy, you can use my promo code, that is DSP, so that you will get a 10% discount on your subscription fees. Now you can use my promo code here DSP so that you will get 10% discount. Okay. Now thank you. Now let's start our first point on this lecture. See, half range sine series, half range Fourier sine series. Now see, what is the formula for the half range Fourier sine series? I purposefully prepare in the table. See, for the interval 0 to 2 pi, so that it is easy to compare. For the interval 0 to 2 pi, Fourier series f of x is equal to summation n varying from 1 to infinity bn sin nx. And the Fourier constant in the half range sine series, only Fourier constant bn is present. So here a0 and an both are 0. Okay, and in this interval 0 to l, in this interval 0 to l, you will get here Fourier series f of x is equal to summation n varying from 1 to infinity bn sin n pi x by l, and bn is equal to here 2 by l integral 0 to l f of x into sine n pi x by L dx. Okay, it is totally depending upon the interval. Now see here, half range cosine series. So if the interval is 0 to pi, then Fourier series is f of x is equal to a0 by 2 plus summation n varying from 1 to infinity n cos nx. And Fourier constant a0 is equal to 2 by pi integral from 0 to pi f of x dx, and a0 is here an is equal to, I'm extremely sorry here. Here an is equal to 2 by pi integral from 0 to pi f of x cos nx dx. Okay, here integral 0 to L, if in the interval 0 to L, f of x is equal to a0 by 2 summation n varying from 1 to infinity n cos n pi x by L, and a0 is equal to 2 by L integral from 0 to L f of x dx, and n is equal to here 2 by L integral from 0 to L f of x cos n pi x by L dx. Okay, now let's see. Now find find a half range sine series for the function x into pi minus x in the interval 0 to pi. Now we have to find out the Fourier sine series. So we can see the table here. Fourier sine series in the interval 0 to pi is f of x is equal to summation n varying from 1 to infinity bn sine nx. Here Fourier constant a0 and an both are 0 in the Fourier half range Fourier sine series, and bn is equal to 2 by pi integral from 0 to pi f of x sine nx dx. Okay, so we can write here your Fourier half range sine series. So f of x is equal to, here you can write summation n varying from 1 to infinity. You will get here bn into sine 2 pi, factor comes in the formula 2 upon pi. Okay, it is the 2 up, see f of x is equal to, this is the Fourier constant. So in the interval, in this interval, the factor is here. In the interval a0 0 to pi, here the formula for the Fourier constant a0, here I'm sorry, for the sine series, here 2 upon pi integral from 0 to pi f of x into sine nx dx. Okay, now here summation n varying from 1 to infinity. Now after integrating this, you will get the factor 2 upon pi. Okay, here after integrating you will get the factor 2 upon pi. 2 upon pi is a constant because here half range series. So depending upon your function in which interval it lies, if it is lies in the interval 0 to pi, then the factor f of x comes here a0 by, here you will get f of x is equal to summation n varying from 1 to infinity bn into sine n pi x by, here directly you can write only cosine nx, because here 0 to pi, so bn into n pi x sine nx, and into, where bn is equal to, you will get integral from 0 to 2 pi, here integral from 0 to 2 upon pi integral 0 to pi f of x sine nx dx. 2 upon pi integral 0 to pi f of x into sine nx dx. Okay, so f of x into sine nx dx, so bn is equal to 2 upon pi integral from 0 to pi. Here your f of x is x into pi minus x, x into pi minus x into sine nx dx. Okay, just integral here bn is equal to 2 by pi integral from 0 to pi, because interval is given 0 to pi here, into f of x is x into bracket pi minus x dx into sine nx dx. So you will get bn is equal to, here 2 by pi, so 2 by pi integral from 0 to pi, here 2 by pi integral 0 to pi f of x into sine nx dx. So you will get bn is equal to, here 2 by pi, so here 2 by pi integral 0 to pi f of x into sine nx dx. So you will get bn is equal to 2 by pi integral 0 to pi f of x into sine nx dx. So you will get bn is equal to, here 2 by pi integrate this 0 to pi, return the first. Now this is your first function and this is your sine nx is the second function. So if I integrate multiplying by x in the interval, so 0 to pi, pi x minus x square. Now your integral becomes more simple. So integrate with respect to what is the derivative of first? So pi minus 2x into sine nx dx. Okay. Now Bn is equal to 2 by pi x minus x square into minus cos nx upon n minus integral of this. Again you have to apply u into v rule. Retain the first into integral of second minus cos nx upon, retain the first integral of second minus integration of derivative of first into integral of second. I'm sorry, here into integral of second minus cos nx upon n, and here retain the first into integral of second. Now integration of cos nx is sin nx upon n into this n. So n square minus integration of derivative of first, that is minus 2 into integral of second. Integral of second is minus sin nx upon n square, right? So we can get Bn is equal to here 2 by pi x minus x square into minus cos nx upon n minus pi minus 2x into minus sin nx upon n square, pi minus 2x into, so this will becomes plus sin nx upon n square, right? This minus and this minus, now this minus and this minus becomes plus again, and this minus and this minus becomes plus, so you will get ultimately plus 2 into now integral of this, integral of 2 into sin nx by n square, you will get minus cos nx upon n cube, right? Minus cos nx upon n cube. So here you will get from 0 to pi. Okay. Now just put the values. Bn is equal to here 2 by pi, from x is equal to pi square minus pi square 0. So this will become 0 plus pi minus 2 pi, but sin n pi is 0. So again it will become 0 plus minus cos n pi. So cos n pi, value of cos n pi here you will get minus 1 raised to n, right? So this is minus 1 raised to n upon n cube. This minus sign, and my cos nx is minus 1 raised to n upon n cube minus, put x is equal to 0. So this will become 0. This is pi minus sin 0 0 and cos 0 is again 1. So you will get minus 2 by, here is also you are getting cos n pi is minus 1 raised to n, 2 into. So here minus 2 upon n cube, right? Minus of minus 2 upon n cube. So you will get Bn is equal to 2 by pi. Here minus 2 into minus 1 raised to n upon n cube. Now this minus sign, and after putting x is equal to 0, then this becomes minus 2 by n cube. So it is plus 2 upon n cube, right? So take 2 outside. So you will get here 4 by pi into n cube. N cube is also outside. So here becomes 1 minus minus 1 raised to n, right? By after taking the 4 upon 2 upon n cube common, you will get this, see, minus 1. So I am taking minus 1 raised to n here and 1 minus. So you will get Bn is equal to this. Now you put it in the Fourier series. F of x is equal to summation n varying from 1 to infinity Bn into sine nx. Now just put f of x value of Bn here. Summation n varying from 1 to infinity Bn is 4 by pi n cube. So 4 by pi is constant. So take outside, and here you will get n1 upon n cube into 1 minus minus 1 raised to n. This is your half range Fourier sine series. I hope you are getting it. Now next, find a half range cosine series of f of x is equal to x minus x square in the interval 0 less than or equal to x less than or equal to 1. Okay, find the Fourier half range sine series, cosine series for f of x is equal to x minus x square into in the interval 0 less than or equal to x less than or equal to 1. Okay, now if you observe here Fourier cosine series, so here we have to find out only the Fourier constant a0 and an. Here bn is equal to 0. So you will get here bn is equal to 0. So here Fourier series for the cosine series, you will get f of x is equal to a0 by 2 plus summation n varying from 1 to infinity. Now in the interval 0 to L, you will get summation n varying from 1 to infinity n cos n pi x by L. Okay, here cos n pi x by L, f of x is equal to this. Now find now calculate a0. So what is our a0? A0 is equal to, you will get here 2 into integral 0 to L, right, into f of x dx. 2 by L actually, but 2 by L, L is here 1, 0 to L. So here L is equal to 1. So you will get 2 by 1 integral from 0 to 1. So what is our f of x? X minus x square dx. So a0 is equal to 2 into bracket integral of x minus x square. So here is x square by 2 minus x cube by 3, right? So you will get here now from 0 to 1. So here 2 into bracket 1 by 2 minus 1 by 3 minus 0, right? So 3 minus 2, here is 1 by 6, 2 by 6, it means you will get 1 by 3, right? 2 by 6 is equal to 1 by 3. So value of a0 is 1 by 3. So I'm writing here a0 is equal to 1 by 3. Now, what is the value of an? An is equal to 2 by L. Here 2 by L into integral from 0 to 1 f of x into cos n pi x by L. Cos n pi x by L dx. But here L is equal to 1. So you will get directly here n is equal to 2 by L integral from 0 to 1. But L is equal to 1. So 2 by 1 integral from 0 to 1 f of x is given pi x minus x square, right? So here you will get x minus x square into cos n pi x. Here L is equal to 1, right? So n is equal to 2 into bracket. Now you will use your u into v rule. So retain the first into integral of second sine n pi x by n pi, right? Here sine n pi x by n pi. So you will get minus integration of derivative of first. So here 1 minus 2x into integral of second sine n pi x by n pi dx, right? I'm taking in the next slide. So n is equal to here 2 into bracket x minus x square into sine n pi x by n pi, sine n pi x by n pi minus here no minus you will get integral of, I'm keeping as it is here, integral of 1 minus 2x into sine n pi x by n pi dx, right? Now here an is equal to, now 2 into, keep x minus x square sine n pi x by n pi as it is, minus, now again here you have to use u into v rule, so you will get written the first into integral of second n square pi square minus integration of, here is I'm writing minus integration of derivative of first, so derivative हो जाएगा minus 2 into integral of second, so integral of second is again minus cos n pi x by n square pi square dx. Okay, so we will get here an is equal to 2 into bracket x minus x square sine n pi x by n pi minus, now this minus sign and this minus sign becomes plus into 1 minus 2x into cos n pi x by n square pi square. Now this minus sign and this minus sign again becomes plus, and this minus and this minus is again becomes plus, and integration of 2 into cos n pi x by n square pi square. So you will get here 2 into sine n pi x upon n cube pi cube from 0 to 1, right? Their integral is from 0 to 1. Now just put the values. So if you put a is equal, x is equal to 1, so this will becomes 2 into bracket, this will become 0 plus x is equal to 1, so 1 minus 2, here it will becomes 1 minus 2, it means minus 1, and cos n pi is minus 1 raised to minus of minus 1 raised to n upon n square pi square, and plus sine n pi, sine n pi 0, so this will become 0, minus, put x is equal to 0, so this will become 0, x is 0, so cos 0 is 1, so you will get only 1 upon n square pi square, right? So this will become 0, so ultimately you will get n is equal to, here n is equal to 2 into bracket minus 1 upon n square pi square minus of minus 1 raised to n upon n square pi square minus 1 upon n square pi square, right? So here n is equal to, you will get minus 1 upon n square pi square into bracket 1 minus, now see here, 1 plus minus 1 raised to n up, 1 plus minus 1 raised to n, right? So this is your n, just put it in the formula. So you will get f of x is equal to a0 by 2. So a0 is 1 by 3, 1 by 3 into 1 by 2 plus summation n varying from 1 to infinity. Here is 2 remains, no? 2 as it is. So 2 upon pi square. So I'm taking minus 2 upon pi square outside. So minus 2 upon pi square into summation n varying from 1 to infinity, 1 plus minus 1 raised to n upon n square. This is your half range Fourier cosine series in the interval 0 to n. Okay. Now next, find the half range cosine series for the function f of x is equal to x minus 1 bracket square in the interval 0 less than x is less than 1. Exactly similar you have to find out. So just f of x is equal to a0 by 2 plus summation n varying from 1 to infinity cos n into cos n pi x by L So find out A0. A0 is equal to 2 by L integral from 0 to L f of x dx. Right? Here f of x dx. So you will get here 2 upon 1. So 2 integral from 0 to 1. F of x is x minus 1 bracket square dx. So here you will get 2 into integration of x minus 1 bracket square is x minus 1 bracket cube upon 3 from 0 to 1. Now put x is equal to 1. So this will become 0. Right? So and x is equal to 0. So 2 into bracket 0 minus x is equal to 0. So minus 1 upon 3. So minus minus becomes plus 1. So here is 2 by 3. So value of A0 is 2 by 3. Next, AN. So what is the value of AN? AN is equal to 2 by L integral from 0 to L f of x into cos n pi x by L dx. So AN is equal to 2 by L. L is 1. Integral from 0 to 1. F of x is x minus x square. X minus 1, sorry. Here is x minus 1 bracket square. X minus 1 bracket square into cos n pi x. Here L is equal to again 1. So dx, so return the first 2 into bracket integral from 0 to 1 x minus 1 bracket square into cos n pi x, return the first into integral of second sin n pi x by n pi minus integral of derivative of first 2 into x minus 1 bracket square 2 into x minus 1 into derivative of x minus 1 is 1. Integral of second into sin n pi x by n pi dx. So 2 into x minus 1 bracket square into sin n pi x by n pi minus 2 into bracket. Now return the first into integral of second minus cos n pi x upon n square pi square minus return the first integral of second minus integration of derivative of first. So derivative of first becomes only 2, right? 2x, derivative of 2x is 2 and minus 2 constant, so derivative is 0 into integral of second. So integral of second, it will becomes minus cos n pi x upon n square pi square dx, right? So again here you will get an is equal to 2 into bracket x minus 1 bracket square n pi x by L, x minus 1 bracket square sin n pi x by L pi minus 2 into bracket x minus 1 into minus cos n pi x by n square pi square, cos n pi x upon n square pi n square into pi square minus integral of 2 into cos n minus cos n pi x upon n square pi square, 2 into cos n pi x upon, now I'm keeping as it is here and then taking the integral, minus 2 into integral of cos n pi x upon n square pi square, cos n pi x upon n square pi square dx, right? So here n is equal to 2 into bracket x minus 1 bracket square sin n pi x upon n pi minus 2. Now this minus and this minus becomes plus 2 into x minus 1, right, into cos n pi x upon n square pi square. Now this minus and this minus becomes plus, right? So this will becomes plus. Again here 2 into 2. So this will becomes plus 4 into integral of cos n pi x is sin n pi x upon n cube pi cube. Right? Sin n cube pi cube. So you will get here 4. No. So put here, otherwise you don't get 2, only 2. So plus 2 into, this is minus sin n pi x upon n cube pi cube. X minus 1 bracket square sin n pi x upon n pi plus 2 into x minus 1 into minus cos n pi. So this will becomes plus, and again here this will becomes plus into this minus sign. So minus sin n pi x upon n cube phi cube. Right? So here is plus only. From 0 to 1. Now put value of n is equal to x is equal to here 1. So 1 minus 1 0. So 2 into bracket here is 0. Right? So 2 into bracket 0 minus plus. Again here is 0 plus 0 minus. Here is also 0. Sin n pi 0. Okay. Now next is put x is equal to 0. So x is equal to 0. This term becomes 0. X is equal to 0. Here is minus 2 upon n square pi square. Here sin 0 0. So this is minus 2 plus 2. So which is equal to 2 into 2 plus 4 n square pi square. So value of n is 4 n square pi square. I hope you are clear here. Here is 4 upon n square pi square. Right? Now put the value of n. So you will get f of x is equal to a0 by 2 plus summation n varying from 1 to infinity a n into cos n pi x by L. So here f of x is equal to value of a0 is 2 by 3 into 1 by 2 plus summation n varying from 1 to infinity. Value of n is 4 upon n square pi square. So 4 upon pi square is constant. So take outside 1 upon n square into cos n pi x by L. L is 1. So cos n pi x upon n square. This is your Fourier half-range Fourier cosine series. I hope you are getting it clear. Now the next is find the half-range cosine series for f of x is equal to, the interval is changing here. Interval is 0 to pi. Okay. Now here interval is 0 to pi. So what is our a0 and n in the interval 0 to pi? So Fourier's cosine series in the interval 0 to pi, you will get here f of x is equal to a0 by, here f of x is equal to a0 by 2 plus summation n varying from 1 to infinity n cos nx. N cos nx, and here where a0 is equal to 2 by pi integral from 0 to pi f of x dx. Right? So a and n is equal to in 2 upon pi integral from 0 to pi f of x into cos nx dx. If the interval changes, the Fourier half-range sine series cosine series also changes. So here a0 is equal to, we will calculate on the next page. So a0 is equal to 2 by pi integral from 0 to pi f of x dx. So 2 by pi integral from 0 to pi. What is your function f of x? Pi x minus x square. Pi x minus x square dx. So 2 upon pi. Now what is the integral value of this? So integral value of this function is integration of pi x. So pi into x square by 2 minus x cube by 3 from 0 to pi. So put pi is x is equal to pi. Pi square into pi cube by 2 minus pi cube by 3. Right? Pi cube by 2 minus pi cube by 3. So here 2 by pi into bracket pi cube upon 2 minus pi cube upon 3. Okay. Minus x is equal to 0. So this will become 0. So you will get 2 by pi into bracket 3 pi cube minus 2 pi cube upon 6. So you will get here 2 by pi into bracket 3 pi cube minus 2 pi cube. It is pi cube upon 6. So here is pi, 1 pi get cancel out, 2 ones are 2, 2 twos are 3. So here is pi square by 3. The value of A0 is here pi square by 3. Okay. So A0 is equal to pi square by 3. Now exactly similar way we will calculate AN. AN is equal to here 2 by pi integral from 0 to pi f of x into cos nx dx. So here 2 by pi integral from 0 to pi f of x is pi x minus x square, right? Pi x minus x square into cos nx dx. So here you will get 2 by pi into bracket. Now integral of this, retain the first into integral of second sin nx upon n, right? Here is sin nx upon n and minus integration of derivative of first. So here you will get in minus integration of derivative of first. So pi minus 2x into integral of second sin nx upon n dx, right? So here 2 upon pi x minus x square into sin nx upon n minus, now again here you have to apply u into v rule, minus retain the first into integral of second, that is minus cos nx upon n square minus integration of derivative of first, that is minus 2 into integral of second minus cos nx upon n square dx, right? So 2an is equal to 2 upon pi into bracket pi x minus x square into sin nx upon n minus pi minus 2x minus cos nx upon n square minus cos nx upon n square minus, now minus integration of minus 2 and minus cos nx becomes plus, so 2 cos nx upon n square, 2 cos nx upon n square dx. Okay, now just integrate it here. 2 by pi integral of pi x minus x square into sin nx upon n minus, now this minus sign and this minus sign becomes plus pi minus 2x into cos nx upon n square. Now this minus and this minus becomes plus, and integral of 2 cos nx is, so 2 by n square, and integral of cos nx is sin nx upon n. So you will get here 2 by n sin n cube, 2 by n cube into sin nx, okay, from 0 to pi. It is in the interval 0 to pi, right? So just put the values. 2 by pi, here pi square minus pi square is 0 plus pi minus 2 pi and cos n pi. Cos n pi is minus 1 raised to n. So here you will get pi minus 2 pi minus pi minus pi into minus 1 raised to n upon n square plus 2 by n cube into sine n pi is 0. So again 0. Okay. Now plus minus x is equal to 0. So this will become 0 plus 2x, here x is equal to 0. So pi into cos 0 is 1. So pi by n square, sine 0, 0. So you will get 2 by pi into bracket minus pi upon n square minus pi upon n square. Right? So minus pi upon n square into bracket minus 1 raised to n plus 1. So you will get an is equal to 2 by pi into bracket minus 1 raised to n. Here is into bracket 2 by pi minus 1 raised to n minus pi by n square into minus 1 raised to n plus 1. Right? So ye pi minus pi cancel out. So minus 2 upon n square into bracket minus 1 raised to n plus 1. This is your value of an. I'm sorry, here an. I hope it is clear to you how to calculate. So f of x is equal to here a0 by 2 plus summation n varying from 1 to infinity an into cos nx. A0, value of A0 is pi square by 3. So you will get here pi square by 3 into 1 by 2. Pi square by 3 plus summation n varying from 1 to infinity. Here is minus 2 outside. So you will get here minus 1 raised to n plus 1 upon n square into cos nx. This is your Fourier half range cosine series in the interval 0 to pi. Okay. Now see, this is a different example. Find the half range sine series for the function f of x is equal to e raised to x for 0 is less than x less than pi. Okay. So here f of x is equal to now half range sine series. So you will get half range sine series in the interval 0 to pi is f of x is equal to half range sine series in the interval 0 to pi is f of x is equal to summation n varying from 1 to infinity bn sin nx, summation n varying from 1 to infinity bn sin nx, only because here a0 and an are 0. So bn is equal to, you will get bn is equal to 2 by pi integral from 0 to pi f of x into sin nx dx. Okay. So bn is equal to 2 by pi integral from 0 to pi. Here f of x is e raised to x into sin nx dx. Right? So now see, here integral is e raised to x into sin bx plus c. So we will apply here the formula for the integration. Integral of e raised to ax into sin bx dx is equal to e raised to ax upon a square plus b square into bracket a sin bx minus b cos bx. Okay, a sin bx minus b cos bx. Here our a is equal to 1, b is equal to n. Okay, so just evaluate this integral. So it is very easy to evaluate. Bn is equal to 2 by pi integral from 0 to pi. I'm sorry, directly we can write here e raised to x. So e raised to x upon a is 1 square plus n square into bracket a is 1 sin nx minus b, it means n, into cos bx, it means cos nx. Okay, that's it, from 0 to pi. So Bn is equal to 2 by pi integral here e raised to pi. Put the integral limits e raised to pi upon 1 plus n square into bracket sine n pi minus n cos n pi minus sine 0 0 minus n into minus n cos 0. Cos 0 is 1. So here 0 into 0 minus n into 1. So Bn is equal to 2 by pi into e raised to pi upon 1 plus n square. There is sine n pi is 0 minus n into cos n pi is minus 1 raised to n. And here is minus n, minus minus plus n, right? So we can take Bn is equal to 2 by pi e raised to pi upon 1 plus n square into bracket. Here is n, if I take n common into bracket 1 minus 1 raised to n. No. N common, n into bracket 1 minus 1 raised to n. So Bn is equal to 2 by pi e raised to pi upon 1 plus n square into n minus n into bracket 1 minus minus 1 raised to n. Now your Fourier half-range Fourier sine series is f of x is equal to, here you will get summation n varying from 1 to infinity bn sine nx, right? So just put the value of bn, summation n varying from 1 to infinity, value of bn. So 2 by pi is constant, 2 by pi is into e raised to pi is constant. So here you will get n into bracket 1 minus minus 1 raised to n upon 1 plus n square. This is your Fourier half-range sine series in the given interval 0 to pi. I hope you are clearly understood by the Fourier half-range sine series and Fourier half-range cosine series, how to evaluate if the two different intervals are given, if it is in the interval 0 to pi and 0 to L. I hope you are clear, because in the last lecture we already covered if your function lies between the interval c comma c plus 2 pi or either 0 to 2 pi or 0 to 2L or minus pi to pi or minus L to L. Everything is covered in last two lectures, and why it is comes factors 2 upon pi comes in the formula, that is also I covered in the previous lecture. You can go through it and check. Okay, and I hope it is totally covered the Fourier series which is required for your GATE exam, and also it is helpful for the engineering mathematics who are appearing for the M2. So I hope it is clear. So if you solve only this type of example, definitely your doubts of Fourier series, how to solve the doubts of Fourier series in the given intervals are clear. Thank you so much. If you are liking my videos, please do like, share and subscribe. Thank you so much.